So welcome to our presentation on the tales of commissioning a net zero energy building. This is a real case study of the Lombardo Welcome Center, which is located at Millersville University in Pennsylvania. My name is Shannon Kaplan. I'm from AKF Group. I was the MEP Systems Project Manager on the design side for this project. And with me speaking about this process is my coworker, Brendan McGrath, also from AKF, and he is actually the commissioning agent on this project. We'll get into how that happened as well, since I know it's rare for the design and the commissioning to be from the same company. All right, and last, we do have learning objectives again for AIA, but this is actually also kind of our agenda for the presentation, so I am gonna go through these. We are gonna start by taking a look at the project itself, some of the strategies that we used on the design side to get to high performance and energy savings, as well as energy production. We're gonna take a look at some of the key commissioning challenges that were associated specifically with this being a net zero building. We're going to discuss some of the teamwork and extra things we had to do because this was net zero, like what set it aside from a standard project. And then we're gonna actually take a look at how the building is doing. As I mentioned, this building is occupied. It has not yet finished a full year of tracking, but we are about 2 weeks away, so we kind of know how it's gonna go. All right, I'm gonna come down here because I really hate standing up on podiums. It just bothers me. I'll let Brendan do that part. All right, so this is Millersville University. As I said, it's located in Pennsylvania outside of Lancaster. It's a pretty rural area. It is a publicly funded state school that's been around since about 1856 and has grown some to include a wide campus. This is kind of showing you the heart of campus. And right here is where our project is located. So if we take a look, we actually have, right here is the main dining hall. This is the student center. We've got the student living here, and we've got campus spreading out here with classroom buildings and sports facilities. This is a quick look at the actual site. Again, Gordonier Hall down there is our dining facility. This Welcome Center actually is home to our student admissions. So they're welcoming all new visitors to the campus. It's also home to student housing. So it's got this dual purpose and dual sides of access, depending on whether you're coming from the residences down to the south or you're a visitor parking in the parking lot on the north side. This project is going for zero energy certification through Living Futures, International Living Futures Institute. So we will be submitting the paperwork for that next month. As part of that certification, we must prove 365 days of continuous energy data demonstrating that we have made as much energy or more energy than we have used on site. We also have to be fossil fuel free in our operation. So there is no generator on this building. It's a battery backup only. And we were not allowed to use any sort of gas sources for any of our heating either. Just a quick look at the project so you can kind of understand the scope and what's going on. It's an approximately 14,000 square foot, one-story building. It is home to, as I mentioned, the admissions department, which is up here on the north side. We have our housing team down here. We've got our marketing department here. This is all shared space for them. We also have a very large glass atrium lobby area that is actually used. It's where all of their campus tours start. So it is a congregating and meeting space. It's not just like a lot of building lobbies where people pass through. People do hang out there. And then at the very end, we have a presentation room, which they do use to have classes in there as well as do these new tour presentations and try and tell people about how amazing their university is. I lied, we do have a second story. It's a basement. It's an MEP only basement. And because of the way that the slope is graded, this basement actually has walk-in entrance from the lower end down here on this side. I will like to give a shout out to the architects of this project. It's the most spacious MEP room I have ever been granted. It was because they wanted to go for a full structural bay. So we all, throughout the project, contractors, the MEP engineers, the commissioning agent, we would go in that space and it just felt so nice and spacious and clean. So thank you, architects. All right, just to give you a sense of the building itself, like I said, it exists. Up here in the upper right corner, we have the main entrance to the building. So you can see this is what people see when they're coming down that main street. when they're parking, this is where they head to as a destination. You can see that big glass lobby here. This is a look inside the office area. We have a mix of open and private offices throughout the building, and that's a corridor running out to the lobby. This one is the actual lobby space, and you can see that we've got a lot of things for people to interact with as well as furniture. And then this is a look at the presentation room for the building. All right, let's get into the stuff that you're really interested in. Let's get into the systems. So we did take a lot of time in looking at how we could optimize the building's energy performance as part of our strategy for net zero. One of the goals that the owner set out was they not only wanted to hit net zero, they wanted to do it on the roof of the building if possible. So even though we're a one-story building, and that makes this challenge a little bit easier, because we've only got one roof, one floor, we did want to make sure we were optimizing the building. We did employ additional sustainable strategies throughout, but today we're going to focus on the energy side of things. So some of the things we looked at were making sure we had good building envelope, energy efficient lighting, and an energy efficient heating and cooling system. On the building envelope side, we did have a lot of glass. We had a lot of conversations about having a lot of glass, and we spent a lot of time talking about glass performance as well as the characteristics of the framing of that glass. So we spent a lot of time looking into ways to minimize thermal bridging. We had conversations about building envelope commissioning. However, we did not commission the envelope. It was not something that the owner was willing to do at this time. We did spend a lot of time with additional site visits to ensure the quality of the installation was meeting the standards that the architect had designed to. We also recognized that with that glass, there was a potential for a lot of solar heat gain. In the winter, that's great. In the summer, that's not great. So we did take some time to design some strategies in to provide some measures of shading for the daylight and glare issues, as well as that solar heat gain. So you can see on our south side, we've got some horizontal bars here on the south windows. Over some of our small windows, the architect put in these smaller little shades. And then on our lobby, we actually have this large overhang that actually does a pretty decent job. There's also fritting on the top levels of the glass in the clear story area, which significantly helps reduce the glare in that space. On the lighting side, I used to say, and this building has LED lighting, but like every building has LED lighting now, that's new. So guess what? This one does too. What is different about this though, is that we really took the time to design the light to hit the levels that we needed and not exceed them. That allowed us to get our lighting power density down to about half what the code that we were designing to was recommending. So even if all the lights are on, we're saving significant energy. But we went well beyond that. We said, we're bringing in all this daylight. We want to take advantage of it. And the shape of the building is such that we have significant daylight dimming zones. All of the blue boxed areas are lights that are dimmed down by our daylight dimming controls. And we are dimming those to off. They're not going down to a 10%. If they're not needed, they are shutting off 100%. So you can see a significant portion of the lights are able to shut off during the day if there's ample daylight. The next thing we did was take a look at the HVAC system. We went with a geothermal well system on this project. I know there are other strategies out there that are highly efficient that we have been starting to use some, but this was of particular interest to the owner. He really wanted to demonstrate this technology to the students and the community at large. So we did go in this direction. One really big challenge with this project is that it's located in an area where the bedrock is shale. And if you know anything about shale, it's that there are a lot of fractures and voids in shale. So it's a guessing game. When you start to drill, are you gonna drill straight through into rock, or are you gonna drill through and find a nice void? If you find a void and don't realize it, when you start pumping in all the concrete, are you just gonna fill that void with concrete? Does the owner wanna pay to fill that natural void? No. So we actually designed our design with a whole series of extra wells on our map so that as they got going in construction, if they found that they hit a void, they knew exactly where to move to instead and could continue to drill. It turns out we were pretty lucky and there was minimal numbers of hits on the fractures and the system's been functioning well. In addition to going with the geothermal on the outside, we of course need something on the inside of the building. So we have a multiple heat pump strategy for this. We've got a lot of different zones. Every different color block here represents a different zone on the system. So you can see our open office areas are each separate zones. And then each of our private office areas, I tried to kind of alternate the colors so you could see where they were. Those are grouped by 2 or 3 offices per heat pump. We've also got coverage for the lobby, our core spaces, and our presentation room. Another challenge that was brought up during this was that they wanted to have some open ceilings in the open office areas and in the corridors, which meant they didn't want to see our heat pumps. It's very insulting, but it happens. So we had to put them all above the ceiling in the central area. So that's where they're all located, plus there's some down in our spacious basement. So when Brendan and I were putting this together, we had a conversation about what you might find interesting here at the commissioning conference. And we decided to put this in, even though it may not make my team look super amazing. I promise we are. But we wanted to get into how things evolve on projects and how when you come into something on the construction side of things, it may look a little bit weird and you're thinking, how did this happen? Why would somebody choose to design this when if you looked at it from our perspective, we just kind of happened to get there. So I'm gonna just walk you through this really quickly. One of the things that came up on this project was there was some kind of strange complications to the mechanical system design that were questioned during construction. What happened was we started out in schematic design with the basis of design. We said, we want this geothermal system. We're gonna have approximately 40 heat pumps, 1 per zone, 1 per office. Each one will have a thermostat. It's gonna be either concealed above the ceiling or vertical in closets. At the end of this, the owner said, that's great. We don't wanna waste the square footage for closets. We are happy with them being above the ceilings. We have a wonderful campus facilities maintenance team. We can take care of it. Great. We get to our design development though, and they've gone through the schematic design and said, we have a budget crunch. I mean, what project doesn't? So we bring this down and we say, well, we think we can reduce this. We're gonna go with the above ceiling heat pumps. We'll take you down to 20 heat pumps. We'll double up those offices or triple up those offices. We'll look at what orientation they are on the building to make sure it's similar heating, cooling conditions. We'll stick with our 1 thermostat per heat pump, and we're gonna squeeze all of those systems into that above ceiling area. So that got locked in. That met the budget. However, we get to construction documents. It turns out that all of the occupants that will be in this building are already on campus. They are real people that we know and have talked to. A rumor gets started that the conditions temperature-wise in this building are gonna be horrendous. They're gonna have to sacrifice. To be in net zero energy, it's gonna be hot hell. We said that's not true, that's not our job, but we ended up going through and having a lot of conversations with them. We did a survey, and at the end result of that, the owner decided to go back to the strategy of 1 thermostat per office, not 1 thermostat per heat pump. So now here we are, we're locked in on pricing to this quantity of heat pumps, we're locked into the design of where they're gonna go, and we've gotta figure out a change. Was not our original intention. We end up at 23 heat pumps, a thermostat in each office, and to solve the ability for each thermostat to do its own thing, we put in a bypass VAV concept that kind of complicates the system. By the time we get to construction, there's RFIs about this. Something similar had been done on another project on campus. It's the same contractor. They're trying to understand the differences between our design and the other design, which didn't work. So they come into it with an assumption that it's just not gonna work, creating a lot of more confusion. The sheet metal shop drawings show up. They're totally not following our design. So we're trying to get all of that sorted out. Brendan's stepping in to try and help get all of this sorted out. And at the end, something that we envisioned being so beautiful and simple turned out to be very complicated. And that happens a lot. And we feel like on the design side, a lot of times we'll get comments that come in on commissioning agents, and it's hard for me to get my staff to calm down and say, they're asking good questions, they don't know all the history, don't get mad at the commissioning agent. And it's also hard for me to say to the commissioning agent, like, look, you need to understand the history. This isn't what we intended originally, so please don't attack us either. We're all on the same team for this. And on this particular project, we are literally on the same team. So looking quickly at the renewable energy system, our main goal, as I said, was to generate all the energy on the roof. So we have a west roof array where the panels are mounted facing 10 degrees east and 10 degrees west in kind of a bifold design. We have the same strategy on the east roof. The center roof is slightly sloped, so we were able to mount the panels flat to the roof. And then as some demonstration and teaching tools, the owner decided to put in a dual axis tracker on site and utilize photovoltaic glass in the spandrel panels of their curtain wall. So those were both thrown in for teaching technologies. And it turns out that that dual axis tracker attracts more attention on the entire building than anything else and has been a really great way to announce net zero energy. So here's a look at what it looks like right after it was installed. The landscaping is much greener now, I promise. But you can kind of get a look at the east-west roofs here and how that bifold design lays out are what actually ends up feeling pretty enormous tracker when you're out there. And then all of this black glass that you see here, that's actually our photovoltaic glass. So overall, we say we're going for net zero, but the truth is we're really aiming for positive. No building I've ever heard of hits the exact zero on making energy and using energy. And I always have this nightmare of being that building that it's day 365, everything looking good, and somebody leaves a cell phone charger in and it ticks over that like 1 kWh and you're like, no. So we're aiming for positive. Our company, when we go for these projects, we have hard conversations with the owner about how important is this to you. For this owner, it was extremely important to hit this as soon as possible. We typically talk about trying to hit net zero within the first 18 months of occupancy. We say that number because we expect the first 6 months to be the final shakedown of the building. We may have moved people in, but our commissioning is not complete. The occupants haven't completed their own unintended commissioning as well. And so we like to come up with a contingency on the numbers in order to say that will help us cover some of the shakedown, but you're also going to need to do your work. Our company typically carries 20% contingency. That has to do not just with those factors, but the fact that there's variability in the weather. Nobody knows what's going to happen these days. Our energy model is simply a prediction. It is not an actually absolute tool, and it includes a lot of assumptions about schedule and occupant behavior and what we think people are going to do. So we like to carry that on. We got to our predicted energy total. We looked at what our predicted roof generation total was, and we found that we were at a 17% contingency. We actually felt very fine with that at the end of construction documents and felt that we would be able to support our energy usage on the roof of the building. But as I mentioned, the owner wanted the PV tracker and the glass. So we put those in and we got up to a final predicted contingency of 27%. So we felt going into construction and occupancy that this building was in extremely good shape to hit net zero. When we were in the design phase, we talked a lot about what was going to make this project feasible or possibly a disaster. We talked a lot about how it wasn't just up to the design. It was up to things like the quality of the construction. They could have a huge impact on how well our building would perform. We talked about commissioning. It turns out that this owner had done some LEED projects and had commissioning before that was required. We were not going for LEED on this project. It was not required, and they said, we don't need it. I said, are you sure? Absolutely don't need it. Are you positive? I said, I would really like to see you do commissioning on this project because I feel that the building's performance is such a key piece of how we're going to achieve this net zero energy, and you want to get it as soon as possible. So we talked about the various options of what we could commission. As I mentioned before, they did not opt for building envelope commissioning. They did not opt for lighting controls commissioning. They felt that the lighting controls vendor is a single component vendor and would do their own good job at commissioning the lighting controls. But where I got them was on HVAC. I said, you've got a complicated system that's put together by a lot of different parts, by a lot of different companies. I really think that this is an important piece on our energy usage pie and we need to commission it. And they said, okay. But they said, if we're gonna do that, we want your company's commissioning team to do it because we're holding you on the hook for getting us to net zero. So we'll trust that your guys will get us there. And that's how Brendan and I ended up doing this together. We made a lot of efforts to keep the relationships separate. We didn't bring Brendan in on design at all any more than we would for any other standard commissioning agent because we wanted to maintain that separation on the project and make sure that we were doing the best we could for the owner on both the design side and the commissioning side. And like I mentioned, we spent a lot of time with the occupancy and operations team as well because we realized they played a big role in the potential success.
So now we're going to get to the heart of it. You guys understand the building, but you're here for commissioning, so let's talk about commissioning. This is a net zero energy building, so it's a little different than other buildings. So we have every challenge that you would normally have on a commissioning job. We have to meet the schedule, we need to do training, it's a quality assurance process, we have to round up the contractors, all those normal challenges plus. We do have an energy model for this facility, but it's a little different than a lead energy model. A lead energy model is all relative. It's all about comparison to a baseline. In this particular building, we have an energy model with assumptions about schedule and a very detailed schedule, assumptions about plug loads. Shannon did tons of work to understand what the plug loads are and how those were gonna work in occupied and unoccupied times. We also have assumptions about the sequence of operation and how that's gonna be implemented by the controls contractor. So I felt it was my job as a commissioning agent to help realize some of those goals. Occupant engagement and training. So what you're seeing here, that's the lobby right there. Beautiful lobby, kind of a gathering space. So they, day one, put their energy use on the screens, totally transparent. You can actually go online and look at their energy consumption. So they didn't say, well, let's wait a year and a half and see how we're doing. Let's make sure we make it before we actually show our data. They did it from day one. So that helped to encourage the occupants of the building to actually understand their energy consumption. It didn't hurt us that the sustainability director is actually in this facility as well. And all his coworkers there knew that he was there. They knew that he was gonna be watching. They had discussions with him. That was part of the occupant engagement. And they knew they were gonna have to be accountable for their energy consumption. Operator training. So this isn't just a one-off building. It's not a building where the admin also kind of does the HVAC maintenance, and they also have a contractor that comes in sometimes, but nobody really knows the building. This is a sophisticated building on a campus with many buildings. They have a full facilities staff. So, okay, great. They have heat pumps on their campus. So yeah, they know how to use heat pumps, but this is a little bit different. Some of the strategies that were employed here were not what you would expect. So what we can see here in this graph, this is actually the set point temperature for the space. And you can see some what looks like cycling. You normally wouldn't want to see that, but that's because the set point is interlocked with the occupancy sensors for the lighting controls. So they go to a standby temperature in the middle of the day. So it's not that the system isn't operating properly, it's that there's a different level of complexity to the system, and it's actually operating properly. So we can't just have an efficient building. I think we've all heard it. The most efficient building is the one where you just hit all the breakers, it's off, it doesn't do anybody any good. The building has to be effective. And if it's not effective, people are gonna figure out how to make it effective. And we did not account for space heaters in the energy budget or little personal fans in the energy budget. So one way or another, these occupants are gonna figure out how to be comfortable. And then finally, for net zero, we've worked on a number of net zero projects. This facility is gonna try to get accredited through the International Living Futures Institute, net zero certification. We have a living building challenge building, and persistence is critical. You talk about drift, and everybody looks at that first year, you make your goal, you get your certification, but how are you doing the second year, and the third year, and the fourth year, and the fifth year? So persistence is critical for this facility. We happen to have Chris in that facility. He looks at the energy numbers on a regular basis. I look at them with him. We brainstorm about what's going on, and it's a process, and I see that continuing into the future. And with that, I'll hand it to Shannon.
All right, one of the other differences is on net zero is we get a lot more involved with the project and the occupants in deep discussions that we don't normally take the time to at the beginning of a project. I mean, we're really trying to make a best guesstimate on energy usage so we can size that PV array. What we found is that this actually really helps with the commissioning process as well. Our design side team spent a lot of time in pre-design really trying to understand the building, the schedule, the needs. We were trying to get that energy prediction together, but that also helped us get a really detailed OPR together, something well beyond the generic template fill-in temperature set points and schedule here. So that really helped us understand what we were aiming for in the energy model, and it helped Brendan and his team understand what they were aiming for for commissioning and working with the building facilities staff. As we moved into the design, we did focus a lot on our energy efficiency and occupant needs, as well as our energy generation. That became more of the focus on the design because we needed to get those documents out there. But when we got to construction, this is a public school. It is state funded. It has very specific bidding requirements. It turns out it is a multi-prime project. Always fun, especially on our side when we get all that information from the contractors directly. And it's also a low bid project. So there was some potential concerns raised by people. Oh my gosh, low bid contractors. I said, that's fine. You know, we've got decent documentation. We're going to be there. But what we also did was we sat down with all the contractors that got awarded the project and explained to them that this was going for net zero. And we invited them to be part of the team. It's not designers versus contractors. This is everyone working together to make this project. So we also invited them as they were looking through the project documentation, as they were preparing submittals, if they saw something that they thought might help save energy and keep the building performing well, we invited them to share that with us, and we did evaluate those. In fact, we had that meeting, and 2 days later, I got 4 ideas from the IT vendor who was like, hey, I've got all these great ideas. Could we look at these options? So it really set the tone for the project off on a little bit of a different foot. And it was all because we knew at the end of the day, if this didn't make net zero, all of us were going to look bad. And if it makes net zero, we're all going to look like rock stars. And who doesn't want to look like a rock star? Maybe not Brendan. All right, when we got to commissioning, we, again, only focused on the mechanical systems, but there was a lot of interaction that had to happen with Brendan and some of the other vendors, such as lighting controls, to make sure that some of those interconnections were happening. So even though that was what we were brought on to do, we stretched the boundaries a little bit, and we have spent a lot of time doing some ongoing commissioning with them, as well as ongoing design tracking for the performance, because we're all very interested in making sure that we have the real numbers to prove that we've reached our goal. Along the way, we did do a lot of very in-depth study. This is a look at an Excel I put together after talking to the occupants. I know it's very overwhelming right now, but we went through room by room. Thankfully, it's a small building. We've done this for larger ones. And said, what equipment are you going to be bringing in? Because we don't know what the occupants will bring in. We only know what we're designing on the design side. With that, we came up with our own watts per square foot. And we also further took the time to understand what that was going to break down in terms of occupied and unoccupied actual load factors. That helped us understand how to better size our mechanical system, which is something that would be helpful on every project, but honestly takes a lot of time and energy. And usually we just go with rules of thumb. But for this, it mattered. We also really talked to them about the schedule. It was easy to say, oh, office building, Monday through Friday, 7 to 6 p.m., done. No. Like I said, admissions is in here. They have weekend events. A lot of parents can't get their high school students to campus until a weekend. They have housing in here. That means that even on breaks when the rest of the university's out, housing department is in there helping house students that are unable to go home for the break. So there's a lot more intensity in the schedule, and we had to sit here and sort it out, and we realized there was also different schedules of hours of operation between the different terms. So we had to really redefine what the schedule was on this project and understand how that was going to impact the energy model and the setup of the BMS system, because it really had to be a lot more programmed than normal. We also did take a lot of time talking to those occupants. We did a survey with them. As I mentioned, there was this vicious rumor. It was going to be 80 degrees in this building all summer long. People were going to just be sweating it out. They were all coming from a converted dorm building where each one had their own PTAC unit, very exciting, in their own private office. And now they would be in shared office spaces or in offices where they would, at the time, have a shared thermostat, which we did rectify. So we wanted to find out what their expectations really were. We figured out how many of them actually worked outside of what were defined as a regular day hours. We talked to them about how many of them were going to take action that would use energy in order to stay comfortable. And we found out that currently 52% of them were actually taking action even in their own private offices. And we talked about what their expectations would be for outside hour time. If you stayed late, did you expect the systems to stay on or not? We went through all of that, and we came up with a potential number of 229 hours of off-hours HVAC system usage. And the university said, could you tell us if we just left the systems on, then what that would do? And we said, sure, it will increase your entire building's annual energy usage by 7.7%. And they said to the occupants, so how do you feel about not having the HVAC systems on after hours? It turns out that they were okay with that as long as they didn't get that 80-degree temperature set point in the summer. That was more of the driving factor. So we followed up with them and came up with a list of things that we were expecting, and this had to get shared through to the facilities team, the controls team, and our commissioning agent to make sure that we were going to uphold this deal we were making with them. So we did go at that point to the thermostat in every office. We agreed to temperature set points of 74 degrees in the summer and 68 in the winter. What's very interesting is they made it through their first summer, and they commented that the building actually almost felt too cold at 74. Something that they didn't think, they were worried about 74. It turns out that the amount of dehumidification occurring in the system kept the air feeling much cooler than they had expected, and they said some people almost got too cold and actually were bumping it up. We allowed them a float of plus or minus 2 degrees on their own thermostats. It also turns out that in the winter, whereas everyone thought 68 would be okay because a lot of them do that at home, they were actually cold. So what they were worried about summer turned out to be fine. What they weren't worried about winter turned out to be cold. Because of all the tracking we've been doing, we realized that we had the ability to bump that up to 70 degrees. So they went to a set point of 70 degrees this winter. It eliminated the majority of the complaints and avoided all of those space heaters being included. And we were still tracking where we needed to be on energy. We also talked to them some about why we wouldn't have the windows open and about what would be happening after hours. There's one woman here that, rumor has it, works 36 hours straight during the housing super crunch. And so she agreed to go without the system after hours as long as there was an override. And she has to get up, it overrides for 1 hour. So if it's longer than an hour and the temperature drifts enough, she just has to go up and validate she's there again and hit it again. So we're forcing her to choose when she's uncomfortable as opposed to having the system decide, since it's one person in the whole building. And with that, I will let Brendan talk about the performance.
Thank you, Shannon. So back to the energy model. We have an energy model for the facility. So this energy model was produced before the building was even a twinkle in the eye of the contractors. We knew what the end uses were going to be. We had an idea about what those were based on those detailed assumptions that we had. So going into this, we knew, or we thought, that HVAC was going to take up about 40% of the energy consumption. We have an EUI for the facility, 36.7, relatively high for a net zero energy building. But if you recall the schedule and the plug loads, that's kind of how we got to that 36.7. So everything was based on that. We also had a prediction for the production of the renewable energy system. So this allowed us to understand when those different systems were going to be producing energy and which systems were going to contribute most to our renewable energy production total for the facility. So our teaching pieces, as you can see, are a little bit less. And this is really interesting. And this is we're talking about using this as potentially kind of a tool for maybe some of the classes at Millersville University. There's 4 distinct PV systems here, all in the same geographical location, experiencing the same weather. So this can really be a study of how different PV systems produce energy depending on the weather. And then we got into metering.
That's fine. All right, so as Brendan mentioned, we intended to keep tabs on this building, and so did the sustainability director. So we designed in a lot of metering to the project. We put in an overall meter. As I mentioned, Millersville University is a campus. It is a campus electrical system. So this building is not connected directly to the public utility. It has its own campus-wide metering. This was great because that meant any surplus we generate just goes to the campus. None of it gets sold back. It's all going to get used right there for their campus. They're going for the Climate Action President's Challenge for the university, so this was a win for them. But we did want to make sure we could understand what was going on overall in this building. We also went and put in different meters for each parts of our PV system. They do want to study the performance of those different arrays. It's all the same photovoltaic panel, so how does the different orientations impact the performance? We also designed in to do branch circuit load metering so that we could see what was happening on every single circuit. And we took care with those circuit designs to make sure that they were single load circuits. So only plug loads, only lights. That's where we also had to talk with the electrical contractor to say, hey, I know you might feel that it's convenient to combine these two things, but here's why we need them to stay separate. And then we all had that planned out for the dashboard display. We have all of our metering running through our BMS system and then pushing out to our dashboard. So we have full visibility to all of the meters, as well as the ability to create virtual meters from the BMS, which are the ones that are being pushed out to the dashboard. Taking a look at how all this laid out, we have our whole building meter. We've got the feeder level meters on each piece of the PV system. You can see all the different breakers. We also have those on the larger mechanical equipment. And then we were banking on not losing the branch circuit metering in value engineering, which has happened on a lot of our projects. So we were really hoping to keep it in, but because we weren't sure, we also designed the loads to go by panel type. So we had all of our lighting loads on one panel, plug loads on another panel, and then what we called the automated building system loads, our water heating, ancillary, security, mechanical systems, all on other panels. So that if we had to go back to the feeder level, we could at least get some basic end use type. It turns out the university was so committed to this being a teaching tool, they kept the branch circuit metering. So we do have the ability to see what every circuit in the building is doing.
And that brings us to the monitoring action plan. Here are the components of it, and I'm gonna go through them one by one. The Lucid dashboard was a critical piece of this. This allows us to see energy consumption by end use, by area in real time. And that's, as I said, it's available online. It's available in the center of this facility. There was tracking by team. As Shannon mentioned, there are various organizations that are in this facility. And we kind of organized these, Shannon organized them as teams so that they could actually see, hey, I left my computer on, more energy consumption is happening for my team. And they even wanted to do some kind of fun competitiveness between the teams that hasn't really taken hold too much, but that was the idea. So here's where we really are. This is the facility. This is how it's doing. As you can see, our EUI, and this is only for 11 months, but our EUI is at 26. So overall, we're using less energy than what we even thought. And you can see where that's happening. Plug loads and lighting. We're gonna kind of dive into that a little bit deeper, but you can see the annual profile there as well. And then as part of the monitoring action plan, there are certain trends that I wanted to review to make sure that the building was being efficient and effective over time. So the very first one, I have a baseline, I have my energy model, I know that it's pretty good. How are we really doing compared to that energy model? We can see here, we can see here that lighting's down and plug loads are down. Lighting, I don't think this was mentioned, but the lighting system, not only does it interact with the HVAC system and the set points, but the lighting controls are actually vacancy sensors. So if there's enough daylight in the space, the users are just not turning on their lights. So there's an action required to turn those lights on, which is a really simple strategy, but really effective to keeping the lights off. Plug loads, we interviewed them and we said, you know, we're seeing the plug loads are way down. What's going on? So they didn't install a dishwasher. Everybody's doing their dishes by hand. They may get tired of that at some point in time, and we do have that in the budget that they can install it.
We call that the sustainability director factor. He walked around and kind of pre-guilted people into not bringing a bunch of extra equipment in, so they didn't bring it in.
So not only do we not have a dishwasher in there, we also do not have a commercial style printer and copier. So we're doing well on the plug loads. HVAC was a little higher. Because our lighting and our plug loads were down, that meant that we didn't have to do as much cooling. So I want to dive into this a little bit deeper because we looked at the overall. For the 11 months, we're a little high. Why are we high? It's really not too bad when we look at the overall. But I wanted to dive into the months and really understand why some months were higher than others. The energy model uses 30-year weather data average. So is weather impacting us here? Is it that we're using more HVAC because different things are going on with the lighting and plug loads? What's going on there? So my first question was, my first move was to have an update to the model. This isn't always something that we have access to, but because we are on the same team and I know the energy modeler personally, I was able to say, hey, we're seeing something different here. I want to kind of do some verification on this facility. Can you do a run with reduced lighting and plug loads and show me where that ends up? So what you can see here, it's a little bit of an ugly graph, but October and November, the difference between the HVAC consumption between the actual and the model was between 30 and almost 50%. In January and February, 20 to 30%. And then we're going to get into July. Ignore July for now. But what you can see is when we reran the model, the lighter green graph there, we're starting to get closer to that 10%. And that's really, if we're at 10% between the model and the actual, I think that's pretty good, especially on a monthly basis. So I said July looks a little funny. Updating our model didn't really help us much. So what's going on in July? I want to put this to the audience. Can anybody give me some thoughts about what they think might be going on here? We have electricity consumption on the left, and below is time. We plotted outside air as well, just to see if there was a correlation there. Take a look and see if anybody can give me a guess on what's going on there. We have higher consumption right here in the middle of July. Thoughts? It's cooling more in July, yep. We're using more energy for HVAC, yep, that's correct, yep. That's a good question, and that kind of gets at what's actually happening here. I haven't gotten to the bottom of why this happened yet. We are looking into it, and we don't want to really throw anybody under the bus, but what you can see here is this is essentially a weekly profile. So lower energy consumption on the weekends. I mean, it is really kind of an office building with a bit of a strange schedule, but it does have a weekly profile. And you can still see that in the middle of July. You can see the weekly profile. So weekends are lower, weekdays are higher. But remember how we talked about the different groups that are in this facility? One of those groups, for some reason, put their schedule on 24/7. So that means that we have to provide outside air all the time. That means that the heat pumps are controlling to their occupied set points all the time. And that's the root cause of what happened here. So I think an opportunity here for Chris or somebody else is to have a little notification when any schedule gets changed. And then ask the question of, why is that happening? Is the building not really effective and that's why you put the schedule on 24/7? Or was it a mistake? What happened there? So it has to be effective. If we just shut off the outside air, maybe nobody notices. It's kind of this silent killer. But when I do these buildings, I think it's important that we get the outside air right, so people aren't falling asleep at their desks. So one thing that we looked at was, we have some unique systems here. Essentially, the whole building is demand control ventilation. So I wanted to make sure that my damper was really responding to my elevated CO2 levels, and you can see that here pretty well. So I feel decently confident that the demand control ventilation is working well over time. I think there is an opportunity here. We only have one CO2 sensor in one of the spaces. All the other demand control is based on occupancy. I'd like to know what's the buildup of CO2 in those spaces? Are the quantities of outside air that we're using for those spaces, is that actually doing its job to flush the facility? All right. So this is simple to complicated. This is the system that we kind of mentioned. Essentially, what you have is a heat pump with two zones, with two independent thermostats. And each of those has a VAV box. If the zone is satisfied, that VAV box will close. There's a pressure independent box that relieves the air into the plenum when that box shuts off. So the heat pump stays at the same airflow the whole time, and it just relieves back into the plenum. So this becomes important when the outside air temperature is around 65, because we had to, I said, I asked the controls vendor as we were going through functional testing, I was like, well, how do you know how to give priority to the spaces? I mean, should we do that based on outside air temperature? How are we going to do that? It wasn't totally flushed out in the design documents. So what we did was we used a 65-degree changeover temperature. Below 65, the priority is for heating. So if either zone needs heating, that's what the heat pump does. Above 65, cooling. And that seems to be working pretty well. If you've ever done an office building, the recovery is critical. Office building, school, anything that's setting back over the weekend, you get those cold weekends in the middle of winter. Monday comes around, the building's not recovered. So I wanted to make sure that we were being effective here as well as being efficient. So I think we did pretty well, actually. There's a halfway decent morning warm-up sequence in the programming. And we actually, on one of the coldest days, it was like 15 degrees over the weekend, we actually were able to recover about 11 degrees in essentially 2 hours. 9 a.m. is pretty decent to be at your space temperature set point. I think we could actually do better here. I don't see that there's any reason that we shouldn't keep those systems, that we couldn't bring those systems on a little earlier and get up to 70 by 8 or 7, or whatever the facility needs. So again, another opportunity for improvement. And our space temperature set points. So, I wanted to make sure that we have this integrated system. It's always hard to get the lighting controls vendor to really talk with the BMS vendor. Sometimes there's only one individual in the lighting controls company that even knows how to do that interaction and do that integration. So this was something that kind of hung on for a little bit after occupancy. It wasn't totally dialed in right away, but we had to make sure that the lighting occupancy sensors were really letting the HVAC system go to a standby temperature in the middle of the day. So that was important for me to look at. I could kind of fake it out and do it when we were doing functional testing, but I wanted to make sure that it was working over time. And it looks pretty decent. There is one room in this building, in the center of the building, just off the lobby. It's not exactly a storage closet, but it's kind of like a storage closet. They hold meetings in there now and then. And we wanted to pay particular attention to that room. We didn't want to have it run on an occupied schedule just like every other room in the building. We actually wanted to have it be unoccupied 24/7. There is unoccupied override on the wall, so whenever they do meetings in this room, they can actually just come up and hit the button on the wall and get their regular temperatures. So that's working pretty well. It's pretty much kind of drifting all the time. So we have that energy model, and the energy model is making assumptions about the sequence, assumptions about how the pumps are working for the geothermal well system in particular. I wanted to see how the VFD on the pump was operating over time, so we can kind of see that. It's a little bit tough to see, but you can kind of see inside the purple. There are green and blue lines that kind of show the speed of the VFD. What we're looking at here is actually kind of a swing season on the lower left, and then a winter season. But not only did I want to see that the pump VFD was responding to the differential pressure, I also wanted to see that the pump was actually shutting off overnight. So that was critical to see here. And you can see that there are a lot of off hours in that swing season when the zones are generally satisfied. But when we're needing to bring on heat pumps to maintain setback temperatures, there's more runtime on those pumps. But still, we're getting a couple hours, even in the middle of winter, that those pumps are shutting off. And then I went to the design engineer and I said, well, if you have a geothermal well system, what are you really interested in seeing over time to tell you that system is working really well? And he said, well, I'd really like to see what the temperatures are of the water coming out of the ground there. I'd like to see how that's changing over time. So we had access to that information. This is essentially when construction was going on in the lower left-hand corner here. So you can see that we're not really getting a daily profile yet. But then once we really get the schedule set up, you can start to see the drawdown on the well over the course of a day. You can see it recover overnight. You can see where the weekends are. You can actually see that schedule override in the middle of July right here. So this was a cool graph. I'd love to see this thing 5, 10, 20 years from now and compare the years to each other. Right now, we're getting about 47 to a little over 70 degree water temperature coming out of the ground. So we think we're doing pretty well. And when we look at these, when I decided which trends I wanted to look at, we talk about critical sensors. If you have an economizer sequence that relies on enthalpy, you might want to look at that relative humidity sensor and do regular calibrations on it. In this facility, outside air temperature and relative humidity are important sensors to look at. But because of the way that we're controlling the HVAC set points, it was very important to make sure that we were looking at the lighting occupancy sensors. And that has a cascading result. So if these lighting occupancy sensors aren't functioning right, if they're stuck on for some reason, giving a bad signal, or if they're stuck off, they're not gonna really work, and that's the one that's gonna be noticed. But if they're stuck on, that has a cascading effect. It affects what's going on with the outside air delivered to that space. It affects the main dedicated outside air system, which is also a heat pump. It affects the fan speed. And then finally, that's also gonna affect the geothermal well pumps. So if we have an issue with a lighting control sensor in a space, we're gonna have cascading effects that go all the way to the geothermal well pump. So that's an important sensor to take a look at and make sure that the persistence is there on the sensor quality. All right, back to where we were. So this is what we're actually producing. Here's our actual renewable energy production. We're doing pretty well, pretty close to the prediction. PV's not dealing with interconnected systems like the building is, so we're pretty good. And then finally, we do want to get back to the end and tell you guys whether or not we actually made this thing or not. So here's where we are. We showed this graph to some extent before. We're at about 26.0 EUI. We're actually consuming about 71% of what the energy model told us we were going to be consuming, so that's a good thing. We're going in the right direction there. On our renewable energy system, we're actually producing a little bit more energy, so we're using less energy in the building, and we're producing more energy on the roof and on the walls. So that adds up to us way overproducing. When I first looked at this, I said, Shannon, what's going on here? Did we just tell this facility to buy too many solar panels? And she was like, well, there's a little bit of a story to that. So, when I see this, I'm kind of shocked, and I say, well, we just wasted the owner's money. But if you recall, we started out with a 17% contingency on the PV. They added in more. We got to 27% contingency based on the energy model. And then the building is actually using less. It's not using its full energy budget. So we're way ahead. We're happy, very happy. We're gonna, at the end of this month, we're actually gonna be submitting this to ILFI. And it's interesting. You can kind of see production versus consumption over the course of the year. There are periods of the year where we actually produce less than what we're using in the facility, but we make up for it in the middle of the summer. I'm interested to see May and June. I think there was a little bit of an anomaly going on last May and June. I think we used way less than what we really thought we were going to use. So I'm curious to see how that works out this year. That's pretty much it. A success story, for sure. Not that it didn't have its complications along the way, but pretty good all in all. So I want to open up to any questions. We got kind of deep into some trends. We got deep into how the building became the building. So now we'll open up to any questions. Right here.
Did you calculate the geothermal system, how much it actually contributes to the energy reduction, and do a cost and benefit analysis?
Yeah, we did take a look at that. And at the time that we were going through to design, one of the systems that was gaining a lot of popularity was the VRF system, which has a similar ability to really significantly reduce the energy used by the HVAC system. We did look at the payback numbers as well, but as I mentioned, the president of the university particularly wanted this to be a teaching tool, and he really wanted to teach about geothermal. So after we looked at the numbers, it honestly financially would have been cheaper to go to the VRF system, and given what we see on the performance, we would have been fine with that system, but it wouldn't have had the educational value that he wanted. So they elected to go to the geothermal system for that project. Oh, it was pretty high. That is the one downside with geothermal. It does a lot of really great things, but the cost of putting the wells in is just significant. And when you add in the factor that it was shale, we had to get a specific drilling rig there for the conditions on site. It did add up.
Yeah, but when you calculate it, you are based on predictions and calculations. And did you actually check with the actual monitor results?
Yeah, part of what we've been doing on the trending for this project is we've been trying to keep track very specifically. Our energy model breaks everything down very specifically because we intended to do the ongoing with this project. which is why when Brendan went to our energy modeler and said, hey, can you recalibrate based on submittals and actual construction details and what's going on, we recalibrated because we intend to trend this. This is why Brendan spent a lot of time delving into different pieces, and he showed you that one from July, but there are other factors that we are trending specifically to look at how the building is performing against the prediction. I mean, as a company, we're very interested in this too. This is one of several net zero projects we have, and we're trying to learn how to improve our own predictions. Because when you're going for net zero, so much of the early design decisions on PV rely on this prediction. And so the better we can get at predicting, the better we're going to be at aiming for the right photovoltaic size.
Thank you.
Yes, over there.
What were the winter and summer outdoor design conditions, temperatures?
I think for this facility, I think it's like 10 degrees and 98 degrees, something like that.
Two quick questions. One, did you have variable speed on the fans for the heat pumps?
They are, actually. Yeah, depending on load. And that's internal to the piece of equipment. Yep. I didn't touch it because they didn't want me to look at it.
We had a lot of conversations about this. At one point, the owner was really interested in putting in solar thermal. We had a heart-to-heart with them about why, with the extremely low hand washing demand load that they had, that solar thermal just wasn't going to make sense. At the end of the day, due to the limited number of sinks and the length of the building, they actually ended up going with a local tank at the kitchenette, and they have instantaneous at the restrooms. So it's a mixed system.
And the bifold on the PV, how much do you have a loss calculation for going with that versus the southern exposure?
Yeah, absolutely. That's actually a strategy that we've developed for net zero buildings. When it comes to the photovoltaic design, the name of the game on net zero is how much energy can we generate per square foot of roof area. So it's no longer about how much can we generate per PV panel. So we are taking a hit. It's about somewhere in the 15% reduction in total production at the worst case point in the year. But because we don't have to worry about panels shading other rows of panels, and we can just fill that roof like a continuous band, we actually make up for it in the number of panels that we can add onto the roof. So overall, when we run the calculations for that, it ends up at a surplus of energy to go to the east-west than it does to go to just the south-facing. There's also snow in this climate, so we do like to have the angle to the panel as well. We wouldn't want to go with just a flat roof, flat panel, because when it does snow, the panels will start to self-clear from heat generation, but we want that snow to kind of slide off. So there's a little gap there. It's kind of the snow trough for the snow to dump into as it slides down. In the back. Yep.
So, I'm sorry, I just wanted to clarify. I thought you said earlier that the user had overruled the PAS to a 24-hour. Do the user groups have access to PAS? Or just the override button on the staff?
Right, so the question is, who overrode the BMS? And the answer to that right now is unknown. As far as I know, none of the actual users have access to the BMS. Chris might, but he wouldn't have, he would have gone the other way. So I don't know the answer to that question just yet. I don't really want to cause too much of disruption there, so I don't want to throw anybody under the bus. But it happened to be, it wasn't the whole building. It was one schedule only for the admissions people. They got overridden.
20 groups or zones have user access to the PAS.
I'm sorry, say that again? The users do not have access to the BMS. Yep. The operators do, though. So I imagine it was an operator. I imagine it was in response to maybe a hot call since it was in July. I'm just guessing because I don't yet know the answer to that. Right here.
You mentioned you use also the battery storage for the solar panels. How many would that?
So the question is about battery storage for the solar panels. We actually do not have batteries on this building. It is a grid-tied building. We're working on another net zero project that's looking to put in the battery system, but it adds a lot of complexity to the design of the system, and a lot of calculations need to go into how much energy you're trying to store how long you're trying to ride the building on the battery system. Because this is tied to their campus system, and any surplus energy literally stays on campus and gets used by them, and they're going for the climate action challenge, trying to get to carbon neutrality by 2050, I believe is their goal. They wanted that energy to just be used on campus. There was no benefit to them. Also, because of that, they're not going to take any advantage out of this small building on campus for demand control, because they're looking at it on a campus-wide level, because they just buy from the utility as a whole campus.
And the emergency lighting's on battery.
Yeah, the emergency lighting, we have a battery backup system, but it's just a central inverter. And that takes care of our lighting and fire alarm and life safety stuff. So that's it. There's just no generator, but it is not, the batteries are not connected to the PV system at this time.
Did you do anything special to address the server room or IT room cooling load, which is 24/7?
So there's a dedicated system that does that, and it is not part of the geothermal well system. So it has its own dedicated system. It does run 24/7. It's a small little split system. It's not even, it's just, it's like a small IT closet. So it's not a big data center or anything like that.
Yeah, the campus, again, because we're on a campus, this is just a local port for that building. And they're actually bringing a lot of that in from the main campus data center hub. So we don't have a significant server load in there.
Yes.
How does the collaboration work with the controls contractor once the building is occupied and you still need help kind of making sure all the meters are working correctly and that your data is lining up month to month?
So that's, you hit on exactly that. So this building was occupied actually February 28th, I think, 2018, right? So just as you said, we didn't have meter data actually until midway through April. So the meters and the lighting controls lagged. But this particular controls vendor works with Millersville University all the time. They have kind of a contract with them. So they have a vested interest there. I think they have a person there every week. So they had a vested interest in this. It wasn't really, there wasn't much contention in the commissioning process.
Yeah, they basically told us during design, this is the controls vendor. You will put one name in the specification and that's that. And it's because it's a campus system.
Okay. So thank you very much. We'll be here for individual questions. We have to wrap up. The next presentation's coming through. Thanks for your time.
Thank you.